So if that's the case, we say that now we square both sides, and then you have to make your thing y the subject to know the limit of y. That will give us the value, the square, the radical of y minus 2 over 3, which is greater than or equal to 0. So if you square to both sides, you have what? Y minus 2 over 3. This is greater than or equal to 0. So multiply by 3 to both sides, and multiply on this side by 3. So this makes what? Y minus 2 is greater than or equal to 0. Make y the subject. So to make y the subject, you'll find something which is very interesting, okay? Would you like to learn, understand, enjoy, apply, and even interested with the beauty of basic mathematics from theory? That the questions that possibly you've been asking yourself as a student, or you've been asking yourself as a parents concerning about your kids. So I know that as human beings, we have so many questions, especially in academics. So you've been looking the answer of that questions, and I would like to tell you in advance that today you met with the right answer. This is the home of comprehensions. It's a home of learning. It's a home of training. It's a home of enjoyment. We make our students to enjoy and be entertained with the subject that you are teaching them. It's a home of applications of what we are teaching in solving real life. How are you, everybody? I'm very happy to have you today. I would like to take this opportunity to welcome all the national and international viewers. You're warmly welcome into Tanzania Online, Ordinary Secondary School in square bracket OLENJOLAI. So here we are in order to transform the life of teenagers and life of serious students who like to apply basic mathematics and science in their practical life, or we call it real life. So I would like to take this opportunity to introduce myself. My name is Olenjolaim Monkotayai Losingo. Simply just call me Olenjolai. I'm a Tanzanian. This is my national, or this is our national flag, or this national flag of Tanzania. We'd like to welcome all the international viewers into a beautiful country for the purpose of tourism. So we have so many national parks, we have so many touristic attractions that you can enjoy during your vacations. So warmly welcome, because you'll find these people who are calm, and that's not only the case, but you'll find the place, because in our country, our God, the God of Abraham, Isaac, and Jacob dwells in our country. And if you want to profit, just remember the only country which has been exceptional during the times of pandemic of the corona. Then you'll find in the map that it's only Tanzania which acted in different way under our president Joseph Pombe Magufuli. So wonderful. So I would like to take this opportunity to welcome you once again. Welcome to enjoy, welcome to listen, welcome to understand, welcome to write down, welcome to reason, welcome to ask the questions. So welcome to learn. So anything else that can help you to learn, this is the comfortable place for you to make sure that you practice. I would like to take this opportunity to welcome you, welcome all our viewers into Tanzania Online Ordinary Secondary School in square bracket OLENJOLAI. Simultaneously, I would like to welcome you into one of our official YouTube channel that's called Tanzania Online O-Level Secondary School in square bracket OLENJOLAI. Wonderful. So what are we doing in this fantastic program? What the visions we have into also? Because Tanzania, the abbreviations of Tanzania Online Ordinary Secondary School in square bracket OLENJOLAI is to also. That's the abbreviation that we have. Wonderful. So really, we are here in order to train, mentor, incubate, encourage, and teach ordinary diploma on how they can extract knowledge, understanding, wisdom from the classroom instructions, and combine it with knowledge, understanding, and wisdom that you are going to teach them to extract it from the Word of God, written in the Holy Bible, in order to solve real life problems. And because you are ordinary secondary students, you have a responsibility to solve a small-scale real-life problems in your community, a small-scale real-life problems in your country, a small-scale real-life problems in your city. You have a responsibility. That's why your parents, your guardians, your relatives, your brothers and sisters, they insist you to study and understand what you are studying. The objective of you to study is not to answer the exams. Just answer the exams, it's a part of learning process. but the applications is solving real life problems. So we are here. The main objective of the also is to train our students to think outside of the box or outside the class on how you can solve real life problems. Again, you have another questions, I know, I guess, because I know that we have our daily students and we have also our new students. So I know that, and I appreciate and I welcome all of you. So another question, Olenjolai, I solved my problem? Yes, I did a research of more than 10 years on the problems that I'm solving. This is the one of the real life problems that I'm solving by combining knowledge, understanding, and wisdom that I extracted myself in classroom instructions in physics, chemistry, mathematics, and engineering. And also I have combined with the knowledge, understanding, and wisdom that I extracted from the Word of God written in the Holy Bible, and now I'm solving your problems. How am I going to solve your problems? I'm going to solve your problems on the learning the beauty of basic mathematics, Form 1, Form 2, Form 3, and Form 4. I'm going to solve your problems on learning physics, Form 1, Form 2, Form 3, Form 4. And I'm going to solve your problems on teaching you chemistry, Form 1, Form 2, Form 3, and Form 4 by using different teaching aids, by using different teaching methodology, by using different teaching techniques, by using different teaching approach, in order to make sure that I transform your mindset and then you see your necessity of learning. Are you ready for that? Welcome. So let us go into this a little part, the last part of the introductions. What are the steps that you have to follow for yourself to be registered permanently into OSO? The OSO is abbreviations of Tanzania Online Ordinary Secondary School in square bracket OLENJOLAI. So the first step, if you don't have an email, then we ask you to create or open a new email, right? Either Yahoo email or Gmail. Then the second step, we ask you to sign in YouTube by using the email you've created. We'll be asked you what? How can you sign? When you get into YouTube, then you find that means we ask you that to open YouTube. And then when you open into YouTube, you'll find the buttons here at the top written sign in. So sign in YouTube by using your email, right? You'll be asked you to fill the blanks of 40 username, your username, and your password. Make sure to keep them, those two unique identifications of yours in the YouTube platforms or in the email, in the world of email. The second thing we ask you to say to also. Don't say to also is not there. It's also is not in YouTube. What is in YouTube is Tanzania Online or Level Seki School in square bracket OLENJOLAI. So copy and paste what you have here. Tanzania Online or Level Seki School in square bracket OLENJOLAI. Once you search, you press the buttons of search. What will you see? You will see to also's welcoming poster and this one. So you see around buttons which has a national flag. So follow this step right now. When you are I'm presenting to you, follow them right now on your mobile phones or on your computer. So then you find the national flag of Tanzania. That's the TZ. TZ means Tanzania. National flag. Beside it, on right hand side, you see the name of our channel that's called Tanzania Online or Level Seki School in square bracket OLENJOLAI. You see the number of videos. You see the number 40 of subscribers. We thank God by His own grace. Currently, we have more than 140 subscribers. It means that those are the permanent students or permanent registered students, because we want you to register yourself permanently, and our registration is free. You have to do it once. Once you do today, then when you be in Form 4, you'll cover all of these contents without hassling and without any need of registration. Then so the fourth step, we ask you to click the flag buttons, the Tanzania flag button. Once you click the Tanzania flag buttons, you will see a horizontal toolbar. This horizontal toolbar, just say I forgot it here, so it means that I have to write it here. So this horizontal toolbar has the first text written at what? Home. So you see home, you see also a video, a welcoming video. You see also a text written what? Videos, and then you see also a text written playlist. You see text written community, or you see text written channels, and also you see a text written about. So you see a horizontal toolbar which has 6 words: home, videos, playlist, community, channel, and about. Community, it might not be there if I haven't created myself as a YouTube creator. I thank God by His own grace means that I'm a YouTube creator also. So the fifth step, this is the very important step compared to other steps, right? So the fifth step, we ask you to look the buttons Look around the video you're watching right now or in our channel. Look the buttons written subscribe. It's red, so its background is ready and the text is white. So click these buttons only once. Then the text will change from subscribe into subscribed. And then the icon of the bell is going to appear beside it on the right hand side of this text. Click this icon of the bell once. You'll be prompted with 3 options. Choose options of all. Then from there, and then you'll see a prompting message from the bottom of the video that you're watching to the top. Just the promptings to a certain distance here that notifying you will receive all notification. Wonderful. So it means from here you have already registered yourself permanently. Why should you register yourself? We have a vision of recording more than 600 videos of training you physics, basic mathematics, and chemistry from 1 to Form 4. So every day we are adding at least 1 video in your YouTube channel. So for you to get notifications once you are online is if and only if you subscribe into our channel. So it's for your advantage to get notifications at any time and anywhere. Wonderful. So again, we know you want to access our contents without too much of the hassle. Even if that's your first day to get into the internet, you're only welcome. In the internet, we have millions of the stuff that can make your life be transformed radically. So click the playlist. So come back into the top horizontal toolbar, which has 6 or 5 words. Home, videos, playlist, community, channel, about. Community might be there or might not be there. And then just click the sideways written playlist. Once you click the sideways playlist, you'll find so many playlists. What the means of playlist in our channel? Playlist represent departments. Playlist representing a subject. Playlist also representing topics. For example, we are teaching you the topic called the relation, the first topics. So we've created a playlist of relations where we collect all the videos of relation from session 1 to session 8 right now that you are seeing, maybe to the last sessions, maybe to be session 12. So you find them, they have been well organized. You see session 1, you watch session 1, you go to session 2, you learn systematically. That's the objective of mentioning the playlist to you, right? Again, we ask you that to click the share buttons to share the video links to us as students or parents via the social media. Example, Facebook, WhatsApp. You can share these video links through email, through Telegram, through Instagram, through Twitter, through TikTok, through Sesson, etc., etc. So just click the buttons or the icons written share, then you'll see the prompt of the icons and below those icons, the names of that social media. So if you do that, you'll find that grateful. Right now, you are an active student and will take advantage of learning these contents and get prepared that you'll be the best students in your final exams, in Form 4 final exams, and be best students in solving real life problems. Well, remember that I didn't tell you that what am I doing here? I thank God by His own grace. He has built in me a gift of teaching. So I am a national and international teacher of physics from 1 to Form 4. I am a national international teacher of chemistry from 1 to Form 4. I am a national, by God's grace, I'm a national teacher of chemistry, of basic mathematics from 1 to Form 4. So it means I'm a national international teacher of 12 subjects in ordinary secondary level in total. So wonderful. Don't get confused. That is God's grace because God is working in me. So I would like to take this opportunity to welcome in one of the departments of our basic mathematics. The subject of the day is called basic mathematics. And dedicate these contents to the pre-Form 3 students or Form 3 students, QT students, reciters, teachers who teach basic mathematics, diploma students, and even VETA students who will be learning or need the concepts of relation. This is chapter 1, we call it relations. We've taught you 9 sessions. We call it session 0 to session 9. And we are in session 8 today that called domain and range of relations. So stay tuned and join me right now to enjoy the contents that are prepared for you. Wonderful. Get prepared. Okay, so my dear students, let us continue with this session 8, where we have to enjoy the beauty of relation. So let me do the quick review to link session 8 with session 7. This session 8 or session 7? It is session 7. Okay, session 7, not session 8. Session 7. So do this minor correction. So the quick review of session 6. So session 6. So what did you teach you in session 6? Basically, we've been concentrating on this subject called the graphs of 40, graphs of inequality relation. Graphs of inequality relation. So that's what we have been concentrating on. Okay? Graphs of inequality relation. Graphs of inequality relation. Okay? Okay, so my dear student, let us continue with enjoying the beauty of relation as the first topic of the Form 3, Basic Mathematics Form 3. And here, ladies and gentlemen, we have been teaching you, let's do a quick review of session 6. And we have been teaching about the graphs of inequality relation. And we say that in this graph of inequality relations, the signs will be used is less than or greater than, or less than or equal, greater than or equal. Okay? What did we concentrate on? We told you that the first step, first of all, change in order to have table of values, we ask that you change less than or greater than or this one into equal sign to sketch a table of values, or to find the y and x intercept, and x intercept. That is one. Then 2, after doing that, that's very interesting actually. After doing that, another thing that which we taught you, insisted you, it means that we taught you about how you draw the lines, right? So we say that if you have less than in the given inequality relation, if you have the sign of less than or greater than, we use dotted line. Okay, we use dotted line. So use dotted line. And then, but if you'll be given the sign of less than or equal or greater than or equal, then use the sign there, use the full lines. So full lines like this, these are the examples of 40 or full line. That's what we have taught you. But again, we taught you about shading system, right? So shading system. So in shading system, what did he taught you? That we taught you that for what? So if the symbol is less than or equal, then we taught you that shade what? Below the line. Okay, below the line. And also we told you if the symbol is greater than or equal, then shade what? Shade the required region. We shade the required regions. It's not like shading in linear programming. Shade what? Shade above the line. So if you remember, we've been drawing graphs like this, and then having dotted lines, and then sometimes having maybe a full line like this. So, but remember also shade what? Another thing that we insisted on, shade what? Shade area of 40 of intersection. Shade area of intersection between the two graphs. For example, if you are shading below the graph of this line, so we shade this way. And also if you are shading above the line of this line, the straight line, like this way, if you do remember, hence we may shade above, but we are not allowed to shade here. So we have to shade this area of 40 of intersection. So this is the area called the area for intersection. And as we taught you, that is session 1. So this is the quick review of session 5 to session 6 because most students confuse this concept. In session 5, we taught you how can you deduce the particular relations from the graph. So use the same principles. You check the lines, use the or draw the line used or the line drawn in the graph, and then so you can predict that here we have less than or greater than, or we have less than or equal, greater than or equal. And then you can check the shading system, then you know, okay, so this is it's not less than, it's greater than, or this is greater than, it's not less than. So that's how you make decision to just develop a particular relation. So today, let me teach you a new subtopic called the domain and the range of relation. Say with me, domain and range of 40 of relation. We'll teach you this concept twice in Basic Mathematics Form 3. We'll teach you this subtopic in the next topic called the function. We'll also teach about domain and range of a function. It's very important. You have to keep this, and you have also to keep the domain, the concepts of domain and range that we teach you in function. So let us start with the first terminology, domain. Have you ever heard anything about domain of range, or is that the word domain? Yes. So some students can say yes, especially those who have been learning about ICT, and especially that the web design. So domain of domain of range. Okay. So you have a question here. So you have a fundamental question. What is domain? What is domain of a relation? What is domain of a relation? Right? So say domain of a relation, which is R, we say that is a complete set. Domain of relation is complete set of possible values so it's a complete set of possible values of the independent variable of relation. That's the definitions of domain. Domain is a complete set. It's not a half set, it's a complete set of possible values of independent variable of relation. In a relation, we have dependent variable and independent variable. Right? So before we show you what the independent variable and what is the dependent common, what the common independent variable in relation and what the common dependent variable in relations, let me give you the second or the other way of defining the word domain. Or other books also define the word domain. The word domain as what? Domain is a possible. So domain of what? Domain of relation or of function, okay? Of relation, but here we are talking with respect to relation. Domain of relation is a complete, not half. It's a complete set of what? It's a complete set of possible values. Possible values of what? Of x. Because x is it's a dependent variable in a relation. So we may use either, or we may choose either of those two definitions in order to have the response. What does it mean? For example, in most cases we write a relation. If you write relation in the form of the equation, relation is a set of x, y, and then we say that here we have what? An equation. So for example, that if you have an equation, y is equal to x minus 3, like this one. So for this case, this x, so x is what's called the independent. X is the independent what? Variable. And y is what? Dependent. Y is dependent variable. Okay? Y is the dependent of the variable. So it means when we ask to find domain of this relation, then we have to find the values of what? The values of, or it means that the complete set of what? Of x. And if we be asked about the range, then I will teach you. So another thing that you have to remember, that you have to know this. Remember that domain of a relation, domain of a relation is a set of x, but we make y the subject. make y the subject of the equation. So we'll have an equation which contains a variable x and variable y. So when we be finding domain, it's a set of 40 of x, but we make y the subject. I will show you and you'll see the meaning of this one. So for example, if you are looking at the domain of this relation, y is equal to x minus 3, domain is the value of x, not the value of y, but we make y the subject. Means that we have to make sure that a variable y is on one side of the equation, whether just the ordinary equation like this one or of 14 of inequality equation. So note that domain is a complete set of possible values of x, but we make y the subject. So I think that at this moment you have a strong foundations, and this is all about what you have to know right now, literally or theoretically, about domain. So this, it has been question 7.1. So question 7.1. So question 7.8, no, question 7.2, what is relation? Oh no, what is range? What is the range of a relation? What is the range of relation? When you say range, we don't mean about Range Rover, the name of the car. No, range, we have range in mathematics. So ladies and gentlemen, I found this definition. Range of relation is the complete set of what? Complete set of possible values. Complete set of possible values of what? Of the dependent variable of relation. This is the first definition, one of the definition. So it's a complete set of possible values of what? Of dependent variable of relation. Or in other words, we say that range, this is another way that we define range of relation. We say that is a complete set of what? Of possible values of x, of y. So the dependent variable is 1. So y depends on x always. So remember that this was what? An example. So example, if you be given a relation with the set of x comma y such that y is equal to x minus 3, then what will be the what? So in that equation, x represent what? Independent variable. Dependent variable. And then y represent what? Dependent variable. Okay? So the range is the value of dependent variable, means the value of what? Of y. So the value of y is equal to what? To range. So range for this case, if you are looking at the range of that relation, this is equal to what? Values of what? Of y. Okay, another key point that you have to note also in range, as how we noted in domain, is this, not before. We say that in range of relation is a possible value, or possible values of what? Of y, but we make x the subject of what? Of equation. So range is a complete set of 40 possible values of y, but we make x the subject of the equation. For example, in this equation, we have y is equal to x minus 3. If you are asked to find out range, so you have to make x the subject. So if you want to make x the subject, it will be y plus 3 is equal to x. So you have made out x the subject. So it means that how many possible values, or what are the possible values of y that can satisfy this equation, that can give us a defined value of 40 of x, right? Defined value, so this is not infinite, so defined value of 40 of x. So what possible values of y? So for this one, we find that it's all what? All real numbers. All real numbers. If you substitute here, you get a value of x. It's similar here. All real numbers of x, it gives you the value of y. So it means that we are switching what? We are substituting real numbers of x, not y. And you're substituting real numbers of y, not x. That's the principle. Even in relations, I will teach you the same principle, but maybe the style of equations will be, of the functions, there will be using a function, it will be a little bit different, because we can have maybe range, we may go up to range and domain of quadratic function. That's all. So you should not get confused. And you have to make sure that you love these concepts of domain and range, because you will encounter it even if you go in advanced education. You study mathematics, you study some other subject, basic applied mathematics. We teach range and domain, or domain and range, of exponential function, of logarithmic function, of quadratic function. But also if you go in undergraduate studies and you take your route, or you take your profession, just want to specialize, or you want to study bachelor in engineering, in any programs of engineering, or in any programs of science, then you believe me or not, you learn the concepts of range and domain. You will encounter it. So when we are building these foundations in your mind, you have to make sure that you keep these foundations until the end of your life. In real life also, you might find some cases that domain and range are useful. Wonderful. So that's the caution, that's the precautions that I'm giving you. It's a one, because I have to teach you, I have one. Do you understand what am I teaching you in relation today? If the answer is yes, please give me the feedback in the comment section below. Wonderful. So that is all about the foundation. Okay? So you may take it, or you may go further and say that so we may say that mathematically, domain of relation, this one, domain of relation, may be defined as what? X comma y belongs to what? Belongs to relation. So x, so domain is a set of what? Is a complete set of x, where x comma y belongs to what? To relation for some y. For some what? For some y. What does it mean? Domain of relation is a complete set of x in such a way that x comma y belongs to what? To relation for some y, not for all the values of y. Also, mathematically, we may define range of relation as what? As y. Range of relations is a complete set of the possible values of y, such that x comma y, this is such that x comma y belongs to what? Belongs to relation for what? For some values, for some values, for some values, for some values of what? Of y. of x, some values of x, and this one for some values of what? Some values of y. Some values for some values of y. So what does it mean? This is just a mathematical definition of what I taught you in this point and this point. Don't think that the concepts of domain and range is easy, and don't think that the concepts of domain and range is difficult. It's neither easy nor difficult. Okay. Example 21. Example 21, we did 20 examples in the previous session. Given that the relation R, is equal to what? Is equal to x comma y, such that y is husband. Y is the husband of what? Y is husband of x. Y is the husband of x. Okay? Then the question asks you that find the domain and the range of relation R. You may pause the video and try to solve this question yourself. Let's read the question again. So a given, so it means that we have a relation which equal to what? A complete set of 40 of possible values of x comma y, such that y is the husband of x. Y is the husband of x. So what is x? X is the wife of y. Y is the husband of 40 of x. What is x? X is the husband of y. But there it is a set of 40 or real numbers. Okay? So solution. So the first step is this. Y is husband of 40 of x. For this fact, x is the wife of y. That is. But here we are not given the limit of 40 of husbands and wife. So y is the husband of x. X is the wife of 40 of y. So we go for the second step. The second step, we have to recall what? Definition. Definition. So definition, we said what? Domain is equal to what? So domain and domain is what? Domain as domain. Okay, we have domain. We say that domain is value of 40, value of x. So what the value of x is wife. So for this case, domain of given range is a set of what? So say this is a set of x comma y, such that x it is set of 40 or wives, such that x is all wives. So you can write like that once. Or another style of writing, you may write a domain. So this is the response. Domain of relation, this is equal to what? Is equal to curly bracket, then we write all what? All wives in plural. So all wives represent what? Domain of a range. Right? Okay. So then we say that we go for the third step. We call the definitions of what? Of range. So what is range? Range is a set, the complete set of what? Of values of what? Of y. So what the value of y there? Y is husband of x. So y represents what? Husband. So the value of y is what? Is husbands. How many husbands are given in this relation? Undefined. So undefined means that large number. So it's a range of what? Of relation, for this case, is equal to what? This one, curly bracket x comma y, such that y is set of what? Let's say even set of all husbands. Y is a set of all what? All husbands. All husbands. Okay? Simply say that range of relation, this is equal to what? X comma y, such that what? Y is a set of all, so such that what? So in other words, you say that range of what? Range of relation is the set of what? Of all husbands. The set of what? Of all husbands. The set of what? Of all husbands. That's the response. So either this or this one. That's the response for that question. So ladies and gentlemen, let me present to you example 22. So it can be a word question like word questions like that one, or it can be what? It can be numerical. Let relation is equal to open curly bracket 0, 2, then comma out 0, 4, comma out 1, 2, then comma out 3, 5. Then we have our curly bracket. What is the domain and range of relation? So the question, what is the domain and range of relation That's the question mark. You can pause the video and try that questions. Let R is equal to complete set of what? 0, 2, 0, 4, 1, 2, 3, 5. What is the domain and range of relation? That's a very simple question, more than you think. But okay, for some students say, sure? Yeah, sure, it's very simple. Solution. The first step, you have to recall what? Recall general form. General form of what? General form of relation. The general form of relation, we say that relation, this is equal to what? Open curly bracket, then you have x comma out, comma 1. Okay? So x comma 1. So mean x comma out, x comma 1. So it means that then we can have some other details, right? So x comma 1. So it means that then we can have such that whatever we can create a condition. But let's assume that once. So it means that we can write also a relation that an relation is a set of what? x1, y1. Then we have what? X2, comma, Y2. Then X3, comma, Y3. Then X4, comma, Y4, etc. So it means that, remember, also, I taught you today that domain is a complete set of what? Of independent variable. So for this case of X. And range is complete set of what? Complete set of Y. It's complete set of Y. So if that's the case, we say that domain of range R, this is what? So this is, so domain of R, this is the complete set of what? Of coordinates of X. Coordinates of X. So what the domain of this point, which is 0, 2, or of this set, so it is 0. What the domain of this set, 0 and 4, it is what? It is 0. So we just write 1, 0. What the domain between 1 and 2? 1 is X, 2 is 1 is the value of X, 2 is the value of what? Of Y. So here it is 1. What the value of X between these two values? Value of X, value of Y. So it means this is what? 3. That is domain of what? Domain of range R. And that's the response. Range of relation. So the range of relation, we say that range of relation is what? So what the range? So what the value of Y between 0 and 2? The value of Y is 2. Means this the range here, this the range, this the range, this the range. So there's a synonym between this range and this range. So we just write 1, 1, 2. 1 or 2, 1 number. So the lowest number is 2. Can write them in ascending order, but just we can write them according to the sequence. The second number is 4, not in ascending order, excuse me. Okay, in the next set, okay, in the next pair, in this pair, the range is 2, so we have 2 already. And also we got the next pair, the range is what? The value of Y is 5. So we have 2, 4, 5. So this is the response. This is the response for this question. Okay. So ladies and gentlemen, let me take you into example 24. Are you ready? Okay, example 24 of domain and range. Please ask the questions in the comment section. Please ask the questions in the comment section. Please ask the questions in the comment section. Please ask the questions in the comment sections as well as you can. So please ask the questions in the comment sections as well as you can in order for you to understand. Okay? So example 23. Ladies and gentlemen, example 23. So example, yes, example 23. So I'll do I'll be doing some questions of domain and range, because I know many students, they fail to tackle these questions. Okay? So find the domain. The question asks you, find the domain. Find the domain and range. Okay, find the domain and range. Find the domain and range of relation. Find domain and range of relation. Find the domain and range of relation y is equal to 3x squared plus what? Plus 2. That's the question. Find domain and range of the relation that given in form of equations, and that is quadratic equation. Y is equal to 3x squared plus what? Plus 2. How can you find domain and range while we are not given some more detail? Solution. You have to understand. Solution. Always, whenever we ask to find domain and range, we have to start thinking about domain first, and then we'll come to range next. Because the domain is the value of independent variable. So we say the first step, remember the general definition that I told you. Domain is value of 14 is value of x. So domain is the value of 14 is the value of x. So it means that from this equation that we'll be given relations which involve a form of question. It can be written, you can write this one that relation, then we have what? We have a set of x comma y such that y is equal to 3x squared plus 30 plus 2. We are allowed to also write in this form. Domain is a value, is a set of values. So domain, so simply say that the definition here, say that domain is set of 40, set of values of 40 of x. So when you reach this point, to find domain of the given equation, domain of relation, domain of the relation above, then you have to think what is the range of values that we can substitute in the equation, because remember that we say domain of relation is a value of x. Remember the technique that I gave you, not. So remember the not. Remember the not before. Domain of range is set of 40, set of x, but make it y the subject. So in the given equations of relations, is y made the subject? Yes. So there's no need for us to make y the subject for this case, because y is already the subject of the equation. So the next equation, what are the possible values of x which can satisfy the equation y is equal to 3x squared plus 2? For many students, the vocabulary of satisfying might be new for you, but don't get frustrated. When you say that we are looking for the value that satisfies, what are the range of values of x that we can substitute in this equation, and we get a definite value of 40 of y? That's the questions we have. For example, if you substitute x is equal to 2, so 2 squared will be 4, 4 times 3 is equal to 12, 12 plus 2 is equal to 14. Is 14 definite? Is 14 a defined value? Yes. It's not undefined. For example, if you maybe introduce x is equal to what? X is equal to negative 5. So negative 5 times negative 5 is equal to what? 25. 25 times what? Times 3 is equal to 75. 75 plus 2 is equal to what? 72. 77. Is 77 a definite value? Yes. So it means negative 5 is one of the what? Of the domain. And also in previous testing, 2 is one of the domain. For example, also you want to substitute 0, x is equal to 0. When substitute x is equal to 0, y is equal to 2. Is 2 defined? Yes. So 0, it's a domain of the equation. For example, if you substitute x is equal to negative 2, so negative 2, if you substitute there, the answer will be 12. Is 12 defined value? Yes. So negative 2, it's a domain, it's a one of the elements, so it's the one of the elements of the domain of the range y is equal to 3x squared plus 2. For example, I substitute a half. So if you substitute a half square, I get 1 over 4. 1 over 4 times 3, I get 3 over 4. 3 over 4 plus 2, then I get 20. So it will be 11 over 4. So is 11 over 4 a definite values? Yes. However, it's what? It's a fraction. So it means that one element of domain is a half. Then what if we introduce what? Even if we introduce the decimal number. okay, the decimal number. For example, introduce 1.3, 1.5. So if you substitute 1.5 there, which is equivalent to 3 over 2, you'll get 9 over 4. 9 times 3 is 27. 27 over 4. So 27 plus means 27 over 4 plus 2 will get 30. Will get, so it means 27 plus what? Plus 8. That will make 35 over what? Over 4. So 35 over what? Over 4. Is 34 over 5 definite value? Yes. So for that case, we have so many values of x that satisfying equation of the relation. For that case, we mathematicians, we say that domain of the range is all real numbers. All real numbers, if you substitute them here, we get the value of y, whether in whole number, whether in fractions, whether it can be irrational number, whether in integers, maybe positive or negative integer. So all the types of real numbers can be found here. So for that case, ladies and gentlemen, we conclude with reasoning that domain of the given relation is what? So domain of the given relation is the set of what? Of all real numbers. All real what? All real numbers. Or you may write this sentence mathematically. The domain is set of what? Is all real numbers. So if you write in this way, in either of this style, in mathematics, we understand what are you saying. So we have found the domain of the given relation. Ladies and gentlemen, now let me take you and teach you how how can you find the range of the given the range of the given relation. Okay? So we say that this is the second step. From the formula that I told you that, I have told you that range is a set of values of values of y, but we make it, but we make x the subject. So we make x the subject. Range is a set of values of x, but we make x the subject. What's our given relation? Our given relation, if you write mathematically, is set of x comma y, such that y is equal to 3x squared plus what? Plus 2. Wonderful. Are you ready to enjoy the beauty of relation? Are you enjoying the beauty of basic mathematics for the form theory? Tell me in the comment sections. Do you understand what am I teaching you? Do you understand the language I'm speaking to you? That I'm speaking mathematical language. Am I solving your problems? Am I helping you, or am I wasting your time? Please tell me in the comment sections, because I need the feedback. Do you have any questions about relations, domain and range of relation? Please tell me in the comment section, please. Okay. So in this case, you say that relations is equal to that one. Okay, wonderful. So if that's the case, so our given equation is y is equal to 3x plus 42. So domain, range is a set of values of y, but we make x the subject. So make x the subject. To make x the subject, we say that, yeah, so it means that we say that make what? So make what? Make x the subject. The subject of what? Of equation 1. Suppose that this is equation 1. So to make x is the subject, we say that we have to, first of all, to substitute by 2 on both sides. We have 3x squared plus 2 minus 2. So on left hand side you have y minus 2. On this side you have 3x squared. So you divide by 3 and then divide by 3. So on left hand side you have y of minus 2 over 3. This is equal to what? X squared. So to make x is the subject, then we have to find the square root of both sides, left hand side and right hand side. So on this side we have the square root of what? Y minus 2 of what? Over 3. This is equal to what? X. So we have already made x the subject, means x is equal to the square root of what? Of y minus 2 over 3. So this is what? Equation 2. So when you reach to this point, now we have a radical. So we have an equation in form of radical. You have to be careful. Remember that domain and range should be a set of real values. If domain and range of the particular relations is outside of that set, then that's the challenge. That's the challenge. It means that domain and range of the equations of the real number, it should be real numbers. So if we have a case that we have complex numbers, then that is not allowed. That's not the domain. Domain cannot be a complex number in this level. Okay, when I say complex number, I understand. It means complex number is n square root of 40 of negative number. Okay, so here we have our equation. Very interesting equation, which is fraction. So square root of y minus 2 over 3. So in this equation, what can we do? So we have to condition. We say domain range, we say range, it's a value of y, but we make x the subject. So what are the possible values of y that we substitute here and get the real numbers of x? So we find that not every value of y that we substitute in this equation will give us real number. For example, if you substitute y is equal to 1, so 1 minus 2, it's negative 1. So it will be square root of negative 1 over 3, which is not a real number, it's a complex number, right? So for that case, we have to condition. So for this case, you say that, means we go for the third step. Okay, so it means that in limit equation 3 to have what? To be defined in real numbers. Only in real numbers. How? So the way that we condition that, we know that the square root of this function, of this relation, should be greater than or equal to 0. Because if the square root is less than 0, it means it's a square root of negative number. That's not a real number, it's a complex number. So whenever you find any equation like this one in relation and even in function, we say that the square root of y minus 2 over 3, this should be greater than or equal to 0. It means we have to condition this radical part or these equations. The aim to conditions is in order to make sure we have real numbers. Okay, so we have y minus 2 greater than or equal to 0. We are looking the conditions because we have to condition the value of y in order to get the range. So make away the subject. So to make away the subject, y minus 2 plus 2 greater than or equal to 0 plus 2. I will do some more questions about this concept in order to strengthen your comprehension. So y is greater than or equal to 2. So it means that, ladies and gentlemen, we say that you have range of 40 of the relation R, range of relation R for this case is equal. So it means that range of relation of R is all real values such that y is greater than what? Greater than or equal to what? Greater than or equal to 2. Okay, all real numbers such that, so it means that this is the set of what? So you say that x, comma y, and then such that y is greater than or equal to 2. Okay, or in other words, you can say that range of relation, this is equal to what? Is a set of all real numbers or real numbers such that y is greater than or equal to 2. This is the response of that question. Ladies and gentlemen, this is the end of session 7, which has been titled as Domain and Range. I'd like to invite you in the next session, which will be session 8, where we are going to solve problems or solve questions about domain and range in exercise. This is we are going to solve from the book, it's exercise 1.2. So don't miss. Make sure that you subscribe into our channel and you should not miss it. And may God bless you abundantly until we meet in the next session. Keep enjoying the beauty of basic mathematics. Stay tuned to visit our official YouTube channel every day so that you can have updates, so you can learn new concept every day, because we are adding one video at least one video in a day. So may God bless you and keep you and protect you and cover you and be with you and give you confidence and open your mind to understand all of these instructions and reveal the problems in your community that need solutions of this information. May God bless you and keep you. This is Olenjolaim from TANZANIA. I love you so much. Keep loving and enjoying the beauty of chemistry. May God bless you abundantly and keep you.